have to, as you know from infancy, improve on your performance. Improve on your performance. But when you come to this side, you have to keep it up. You keep up your performance because it's good. So my information is between the average and where you are exceeding the average. The distance is what we call the variability. You have moved away from the average to the positive direction. And you can also move away from the average to the negative direction. And that is the concept of average and variability. Anytime you hear about average and variability, this is what it means, that you have the average as the expectation, and then you have the variability as not something we are expecting but can happen or occur naturally. Since we are dealing with figures, we want to use a system to work out the variability as well as the average of any business data we see. Remember, any data that gives you an idea of maximizing profit and minimizing costs is a business data. And so this afternoon, we want to learn how to process business data using the average concept and the variability concept. And the two formulas we want to use today are as follows. For the average, there are several methodologies that are used, but we are going to restrict ourselves to the fundamental. So the fundamental average calculation, you know, from first cycle, is called the arithmetic mean, which I'll shorten with AM. It's called arithmetic mean. So it's giving us x bar is equal to sigma fx divided by sigma f. This is what is used in calculating the average of every business data. And once you have the average, that is the basic information you need about any data you want to understand. This is the basic information. So let's look at this question and then we apply the formula. It says the following revenues in millions of dollars are generated by an oil company for 100 months running. All the numbers are in millions of dollars. So let's look at the numbers. So it starts from 107. This is 100. Look at it. 100 months. 100 months data. So first month was $107 million. Second month was $54 million. Third month was $66 million. Fourth month was $74 million. Fifth month is $83 million. So it keeps going like that. And as you look at the figures are rapidly changing. They are not constant. They are changing. And any variable that changes, it means that it is going through variability. It is not stable. It is going through variability. So because these numbers are going through variability and they are changing, the question is that how can we get one single number? How can we get one single number to represent all these numbers? All these numbers, which are 100 pieces of data. How can we get one single number to represent all of them? That is where the average comes in. The average comes in to represent all these numbers. So a typical question like this can be asked, that construct a frequency distribution table for this data, starting with the following intervals: 40 to 49, 50 to 59, 60 to 69, and so on. And then, secondly, find the arithmetic mean. That is, find the average after doing all that. So quickly, once you have been given the class intervals, you quickly go and construct your frequency table. So you arrange it 40. The instruction was that start from 40 to 49, 50 to 59, 60 to 69. And then the question stopped. 40 to 49, 50 to 59, 60 to 69. Now the three dots you are seeing here means and so on. And so on. It means that continue. Okay. Continue. So where are we continuing to? Where are we stopping? Where are we stopping? That is the first question you ask yourself. So when you are doing the arrangement, when you are, those of you have forgotten how to do the class intervals, when you are doing your class intervals arrangement, just look at the incremental jumps from one previous interval to the other and know the pattern or the trend of what is happening. So if you watch here, between 40 to 50, 10 was added. Between 50 to 60, also 10 was added. Same thing when you come here, between 49 to 59, 10 was added. Between 59 to 69, also 10 was added. So it means that on the left and then on the right, as you keep going down, you add 10 to the previous one as you go. But my question is, where are we going to stop? Where are we going to stop? So you look for the highest number. You scan through the numbers and then you look for the highest number. For instance, when I come to this first block here, the biggest number I'm seeing is 107. So I'll keep checking with it to the right. So when we keep going after the 107, the next big number we saw is 101, which is less than the 107. So still 107 is the highest as at this point. And then we keep moving to the right, keep moving to the right. And then I've spotted 104 also. Because 107 is bigger than the 104, we still keep going, having 107 in mind as the highest. So we keep moving to the right. And then finally, I have seen 116 here. So it means that 116 is the highest number of this data. Therefore, as you keep doing your class intervals, do it in such a way that you get a certain class here which can accommodate the 116. Once you see that, you quickly stop constructing the table because you've been able to capture the biggest number. So that was what I did here with this table. Started 40 to 49, 50 to 59. So you keep coming down, you keep coming down. When I got to 100 to 109, I didn't stop because I was looking for 116. And so I had to go to the next one, that is 110 to 119. And at this point, you just stop and then you rule your line to separate it from the total. Then after that, as usual, what you knew some time ago, you are now going to do your frequencies, counting the numbers between 40 to 49, 50 to 59, and then you record them as you are seeing them here. And so when you also record all the frequency, you get to this point. That's the last one. And then after that, because you have ruled the line here, this is representing the total frequency. It means that you need to add everything here to get the total frequency, which we write it as sigma f. Sigma f. Sigma is a Greek symbol which means sum up or add, addition. Sigma means addition, so it means add all these frequency values, and then this is what we had. Now, the question said we should look for the arithmetic mean. This is the question we are answering. Find the arithmetic mean of the data. In other words, find the average of the data. So quickly, we remember the formula we have written today, that whenever you are finding the average of the data, it means you are finding the arithmetic mean, which is written as x bar equals sigma fx over sigma f. So then we go look at our table. That when we were constructing our table, we started this way. We started with the class intervals. Let me demonstrate it here before we go to my original table. When we started with the class intervals, and you were seeing us write the initial intervals 40 to 49 and so on and so forth. And then we came to the frequency. We then went to count all numbers within the intervals, and then we recorded them. Okay. And then I told you that when you get to the end, after adding all the frequencies, you write it as sigma f. When you come to the formula, that sigma f is the one you are seeing here as the denominator. So that is sorted out. But what is not sorted out is the numerator, sigma fx. Sigma fx means that we should go look for f, we look for x, we multiply the two, and then keep it. So first of all, before you can get fx, we need to create a column for x. And then after creating a column for x, we'll multiply the f by the x to have our fx this way. And then we can also rule the line. Once we added the f to get the sigma f, we also add up the fx to get our sigma fx. So once that is attained, we just come and fix it in the formula. We fix this one here, and then we fix this one also here, and that is going to give us our center or the average. So that was how the table was constructed. First of all, you do the class intervals, you do the frequency, you create the x, and then you multiply the f with the x, and then that will give you the fx you are seeing here. Now, those who have forgotten how to create the x is called the class midpoints. Class midpoints or class middle points. Okay. And this is how to get your x, class middle points. All you do is the two numbers you are seeing here, just put them together and divide by 2. So if you pick 40, you add 40 to 49, and then you divide by 2. That is going to give you 44.5. If you pick 50 and you add it to 59 and you divide it by 2, that is going to give you the 54.5 here. So that is how to create the x. So you create your x, and then after creating your x, it's now the time to multiply the f with the x to get your fx. So this is the multiplication. You pick 1, you multiply 1 by 44.5, and that will give you 44.5. You pick your 8, You multiply it by 54.5, and that's going to give you 436. You pick your 27, you multiply with 64.5, and you have 1741.5. So when you're able to successfully record all your FX values, then you come to the bottom to total them. Once you total all this, we call this one the Sigma FX, because you have managed to put all of them together. So you start from the top, you keep adding, you add 44.5 to the second one, you add the second one to the third one, to the fourth one, to the fifth one. So you keep coming down. You keep coming down, adding all of them up until you get to the last one. And you are going to record this number 7540. So as at this point, you have your Sigma FX on my right. And then when you scan to the left, you have your Sigma F also here. And these are the two things you need to find your average: Sigma FX and then Sigma F. So you quickly write the formula, and that's what I did here. You write the average formula. The average formula is written as X bar equals Sigma FX divided by Sigma F. So the Sigma FX we had 7540. The Sigma F we had 100. When you use your calculator to divide, you have 75.40. 75.40. So this is certainly the average we are looking for. The single number that is representing all the numbers that were recorded for 100 months. The average is 75.40. So if you want one language, if you just want one language or a single statement to speak about this data you are seeing here, which has been recorded for 100 months, all you say is that the average revenue, average revenue the average revenue per month for this institution can be recorded as $75.4 million. $75.4 million. It's representing all these numbers you are seeing from the left to the right. And that is how we speak our business language. So if there's any increment in fuel and they say there's been 5% increase in fuel prices, this is an average calculation. If they say there's been 10% increase in electricity, this is the average point. And that is what we are learning to do. But this average point story, sometimes it can be misleading if you don't add what we call additional information. You need additional information to support the average so that the average can now become complete. And that was the first thing we were trying to do last week when I brought you to this grade system issue. That if you look at this grade, if I tell you that this school, you are only required to have C plus and B minus, and then I don't give you information about B, B plus, A minus, A, or I don't also give you information about C, C minus, D, and F, then it means that I have not given you the complete story about the grading system in our school. That is why I've put them in blue. That you need the blue in addition to the pink to be able to give a complete story. So the average alone is not enough. You need supplementary information to the left of the average. You need supplementary information to the right of the average so that you can understand the data fully when it comes to understanding the figures you have. And so I have written something here for you. Probably when you read your notes, which I have hosted on the LMS, you will understand what I mean by that. I said here that this average we have calculated, the average we have calculated, sometimes it's not representing the full story. So I used a word which you see. I said sometimes the average we have in the system can be a misleading result. It can be a misleading result without the additional information. Once you don't add the additional information, it is going to be a misleading result. That is why when those of you who are a bit economical, or those of you who are in the finance area, or you care about what you call indicators, economic indicators, you see that when they say inflation has dropped to 3.3%, okay, inflation has dropped to 3.3%, the government statistician doesn't end there. He will then start mentioning inflation in Greater Accra, inflation in Ashanti region, inflation in Volta region. Now, those are the additional information I'm talking about. If he doesn't mention these ones to the 3.3%, then this result will be a misleading result. Nobody will understand how this average was computed. So for every average, we need additional information so that we can be able to understand the data. And so the next thing I want to do is to compute the additional information. Now, the additional information, we call them measures of dispersion. Measures of dispersion. And you can even look at the word disperse. Where are we dispersing from? We are dispersing from the center. This is the center. See, we are moving away to the left. We are moving away to the right. So we'll get to a point here. We'll get to another point here. So what is taking us from the center to that point? That is what I have consistently mentioned as the additional information. You need additional information to the left and then additional information to the right so that you know how the center is spreading. Because the center must spread out. It is not stable. It must spread out to the left and to the right. Now, there are so many statistical techniques that are used to find this additional information. The first one is called the range. The second one is called the variance. The third one is called the standard deviation. The fourth one is called the mean deviation. The fifth one is called the coefficient of variation. But for the purposes of our studies, we are just going to cover one of them. Just one of them. And that is the standard deviation. We want to see how the standard deviation can be used as a spread of the data from the center in order for us to get the additional information we need to support the average we have calculated. Remember the average we just calculated, which was the arithmetic mean. We had 75 million, 75 points, 75.40 million as the monthly revenue that is accrued from the sales of the oil. So let's see how the additional information of standard deviation can help us to understand the data using the average. For the standard deviation, there are several methods that are used in calculating them, but I want to walk us through only one of them, and I hope you understand it. So the standard deviation formula is given as follows. S, like this, is equal to the square root. Lisa, are you seeing what I'm writing?
Yes, sir.
Yes, please.
All right. Okay, thank you. S equals sigma fx squared divided by sigma f minus sigma fx divided by sigma f all squared. Now, don't worry, during your examination, I'll give you a formula sheet. All the formulas we are using, it is not your responsibility to memorize them because I'll give all of them to you. Your responsibility is to know how to use the formulas. So just watch me as I apply the formulas to data. So I'll give you a formula sheet during the exam. All these formulas will be written for you, and then you can refer to them. So this is the formula used in finding the additional information we are looking for, which is called the standard deviation. And so we are going to look at the structure of this standard deviation to see how we can integrate it with our table, because we need to create a table for this formula so we can pick the figures. Anytime you are going through a formula and you see this symbol, sigma, like this, it means automatically you are going to form a table. Once sigma appears, it means a table must be formed. So you can do some manipulation and get a total figure, and then you come and fix it over there. Now, the table we just did, I'm seeing some traces here. Look at this one. The previous table we did, we saw sigma f. So no problem. This one, we know how to find this. And then the same previous table, we also did sigma fx. So we don't have a problem with this one too. And then when you come here, sigma f is the same thing you are seeing here. So we don't have a problem. But the problem is the first one here, sigma fx squared. Sigma fx squared. We need to learn how we can rewrite this one. Now this fx for your information, this fx like this, fx squared is the same as taking this fx like this, and then you multiply it with x. When you pick fx and you multiply it with x, you come out, this x will be 2. So x times x will then become x squared. So all I'm telling you is when we go to the table and we construct our table, we will look for fx, we will look for x, and then we'll multiply the two of them to give us our fx squared, so that in that case we can then sort out this sigma fx squared here. So let's go back to the same question, which can be asked in another form. Same question. The following are revenues in millions of dollars generated by an oil company for 100 months running. All numbers are in millions of dollars. This is the data. This time, they say do same thing. Do your frequency table by starting from 40 to 49, 50 to 59, 60 to 69, continue. And then these are the demands. They are asking you to find the variance of the distribution, which is one of the dispersions I said we will not do. But what we will do is the B. Find the standard deviation of the data. This is the additional information we are looking for us to understand our data. This is the additional information we are looking for to understand the data. So quickly, we do our table like I did the first one. So you arrange 40 to 49, 50 to 59. You keep going till you get to the last one, 110 to 119. And then you count the numbers in between the intervals between 40 to 49. When you count, you get 1, like the first one. Between 50 to 59, when you count the numbers, you get 8. So you create your f as you go down, and then after that you come and create your x, and then you use your f and your x to multiply them to get your fx, like we did for the first table. But the formula we wrote, the formula we just wrote, we saw sigma fx squared. So it means that we need fx squared in the table. And that was what I said. I told you that fx squared is the same as taking your fx column, multiplying it by your x column. And this is the demonstration. So I have the 2 here. So watch it. I've picked my fx column. I have picked my x column. And then you multiply these two. You multiply this by this. And that will give you the fx squared. fx squared. So it means you have the fx squared now. And then when you come down, you keep adding them until you get to the last one. This is the value you get. So this value is representing sigma fx squared. This value is representing sigma fx. And then this value is also representing sigma f. So all we do is that we go pick our formula for the standard deviation and then we fix them. Now this is the formula. We said the formula was S is equal to square root sine open. We have sigma fx squared divided by sigma f minus, you open bracket, sigma fx over sigma f all squared. Then we quickly put in the values. So look at how the values were then substituted. This is what I did. Sigma fx squared is 586,135 from the table. Sigma f is 100 minus sigma fx. So let me repeat it here so you can have a feel of the substitution. Let me rewrite the formula here as S equals square root sigma fx squared over sigma f minus sigma fx over sigma f all squared. So this is what I was trying to do. That this value you see here, 586,135 from the table, is representing the sigma fx squared. This 100 you are seeing here is representing sigma f. This minus sign is what you are seeing here. And then sigma fx is what you are seeing here, 7540. The sigma f is what you are seeing here. When you calculate everything, this is the final results you get, 13.37. In other words, we want to say that the standard deviation is $13.27 million. This is what it simply means. It means that if you want to move away, if you want to move away from the average, if you want to move away from the average, it means that you can move 13.27 million to the left, or you can move 13.27 million to the right to complete this data story. And let's do that movement so that you understand what I have written here. Let's do that movement. Now, this is what I want to do. Let me create the space now. Okay. So the average we had 75.40 million. So this was the average. This is the average, or the average sales. Okay. And I did mention when I was starting that average in life is what everybody expects. So it is called the expectation. Others in the business world also call it the target. We are setting a target for you. The target is the average. There are other two scenarios that can happen. Either the average will move to the right, or the average will move to the left. When the average moves to the right, we say you have exceeded the target. So to the right means you have exceeded the target. When the average moves to the left, we say you have not met the target. Have not met the target. When you stay at the average, it means you have met the target. So for our data, this is the average we had from all the data that was given to us. And remember, 100 months is 8 years. So this is coming from 8 years data. 100 months. After 8 years, we have got to realize that averagely, the organization is making $75.40 million. But that is not enough, because there were other numbers that were used to compute the average. So we must know the variability, the changes that are happening. When the changes are positive, what is happening? When the changes are negative, what is happening? And that is the standard deviation we found. So we do standard deviation to the left, standard deviation to the right. Standard deviation to the left means we are to the right means we are adding, and we had 13.27. And then standard deviation to the left means we are subtracting the same 13.27. So when you do that calculation, when you have 75.40 and then you add it to 13.27, you have 88.67. 88.67. And then when you also do same thing here, you subtract 13.27 from 75.24. This is the result you get. You have 62.13. So this side becomes 62.13. Now look at the story now. Now it means that if you have 62.13, you are below the target. What is the target? The target is 75.40. If you have 88.67, you have exceeded the target. So it means that in our data, what this story is telling us that we may have numbers that are 62, 63, 64, like continuously till we get to 75. And we may also have numbers that are more than 75, starting from 76, going to 77, 78, till you get to 88. So when you check the data we were working on, you see that these numbers I've written here, you see some of them in from 62 to 75, and then from 78, 76 to 88, and so on and so forth. When you come, you see same numbers in the data. So just for a quick check, 62 below the target, 75 target, 88 exceeding target. You see them. So if I try taking those numbers out, this is 62, this is 65. So I'm just trying to go to the target. Target is 75, exceeding up to 88. So this is also within the range. I'm just trying to work in this range. This is within the range. This is also within the range. That is within the range. This is within the range. This. I want to teach you something else. So let me map out all the targets, and then those below the target, and then those above the target. And then I'll teach you something else. This is also in the range. This is also in the range. Probably let me use a circle so that you can see the numbers. 86, 85, 78, 66, 66, 71, 79, 66, 65. All of them are either below the target or the target or above the target. So we have 70, we have 86, 88, we have 80, all of them. I'm working with this range. Those of you who are losing track, I'm looking for numbers between 62 to 88. That's what I'm doing now. So 77, 50. Okay, this one doesn't qualify. Then we keep going. Come here, 82, 63, 66, 84, 87, 81, 72, 78, 77, 79, 88. They are still within. So look at 61. I can't pick 61 because our range is 62 to 88. 64, 62, 78, 63, 74, 65, 82, 79, 72, 68, 84, 63, 67, 79, 65, 77, 88, 74, 83, 69, 75, 73, 62. So look at what we did, the range. Now we have the target, the average, which is 75. All numbers from 74 to 62 are below the target. All numbers from 76 to 88 are above the target. And then we came to look for those numbers. But unfortunately, we didn't cover all the numbers. So the question is, how do we report for the numbers we couldn't cover? Because the demonstration I did, if I'm to repeat it, I said this is the average, 75. These are the range to all those who exceeded the target, 88. These are the range to all those who fell below the target, 62. And so, is this the complete story? If that is the complete story, then the question is, how do we account for numbers like 107, which is not in the range, 54, which is not in the range, 91? Let me even single them out so that you can see them. We couldn't cover 107. We couldn't cover 54. We couldn't cover 90. We couldn't cover 91. We couldn't cover 97. We couldn't cover 89. We couldn't cover 57. We couldn't cover 101, 94 as well, 61, 89, 59, 94. All of them are not in the range. 61, 104. Okay, so I missed 85. 85 is supposed to be part. We couldn't cover 59, 61, 99, 98, 59, 45, 102, 51, 57, 92, 116, and 89. There are many. We cannot ignore all these numbers without reporting them, because even though we have reported a lot in red by using our two formulas, the others two that are left, we can't ignore them. We need to report them. How do you report them? So that is the next thing I want to teach you. When it comes to standard deviation, in normal life, we have 3 standard deviation. This is natural. Natural occurrences, you are supposed to have 3 standard deviations. Anything beyond 3 standard deviations, we have a name for it. We call it an outlier. And I'll give you an example. Anything beyond 3 standard deviation, we call it an outlier. Now let's take the design of t-shirts. You know that in the design we have large, we have medium, we have small. So all we know is that either your size, your t-shirt size is small, or it is of medium type, or it is large. This is what we naturally know. So these 3 things are representing something like the first standard deviation, the first standard deviation. This is also representing the second standard deviation. This is also representing the third standard deviation. So now let me now create the picture for you to see. We know small, medium, large. This is what we have known all this while. So this is representing the average, which is natural in the system. When somebody tells you, my shirt size is small, you don't question the person. When somebody says, my t-shirt size is medium, you don't question it. When the person says, my t-shirt size is large, you don't question it. You are okay. Now, this is where the question arises. When somebody says, give me extra large. Then a question arises in your mind, or give me extra small. Another question arises. And then somebody will say, oh, as for me, I am extra large. More questions come into your mind. Somebody too will say, extra small. More questions come into your mind. And then somebody will say, extra large. More questions come into your mind. Another person says, extra small. So your mind can accommodate extra large, even though you think about it. Your mind can accommodate extra large. There are people like that, or there are bodies like that. There are others who are also extra large, which you would like to see because it's not common. Others who are extra small. Okay, so this look natural, but if somebody tells you that my shirt size is extra large, this doesn't look natural. So that is what we call the outlier. It means that it is not lining up with the natural order. So any set of data that you have, after moving 3 standard deviations, any other number you see is called an outlier. Let me give you another numerical example, and then I'll come back to what I want to finally teach you. If I have a number line like this, and I have 0 here, this is 1. This is -1, no problem. This is 2. This is -2, no problem. This is 3. This is -3. The moment I do this 20, you will disagree with me because the increment we are seeing is +1, +1, +1. So why is it that to the next step, the 3 instead of going to 4 has jumped to 20? No. If you are working with such figures, you will concentrate on the one that has what we call a normal pattern. That has a normal pattern. Because the 20 doesn't follow the normal pattern, we call it an outlier. It cannot be part of the data we want to work with. So in order to cover all the numbers I have squared with the mauve color, in order to be able to tell a story about 107, 54, 90, and the rest, this is how we are going to tell our data story. Now we will say that the data we have, the average is $75 million. And then if you move 1 standard deviation, the range of values you cover are from $62 million to $88 million after moving 1 standard deviation, because we added 13.27 here, and then we added 13.27 here. Okay. So in order to cover the colors in mauve, we have to move 2 standard deviation and then possibly move 3 standard deviation. After 3 standard deviation, any number that we do not cover, we say that that number is called an outlier because it is not within 3 standard deviations. All these numbers you are seeing here, if they are part of the natural order, they must be part of the 3 standard deviation. So in that case, this is how we go again. We have 75, 0.40 here as the center. The first standard deviation, when we added the standard deviation, the right here we had 80. Let me write it bigger so you can see. Sorry. Let me write it bigger. Let me go back to the page we had those numbers and write it bigger for you to see. Okay, so let me create the space here, and then you understand what I'm saying. Let me clean all this stuff and then write it well. Okay, so let me continue and finish within the next 10 minutes so I can open the floor. So I said the average we had 75.40. When we added the standard deviation to the left and to the right, like this. The first one here, we had 88.67. And when we came to this side, we had 62.13. And I said we did one standard deviation. So we subtracted one S here, we subtracted another S here. So this is what we call one standard deviation. One standard deviation. Now let's do two standard deviation. Two standard deviation is that then we are also moving again by adding another S here, and then moving again, and then adding another S here. When we do that, what will we get? So this is what we do. This 88.67, we add another 13.27 to it, which is the standard deviation. And when you do that, you have 101.94. So 101.94. And then when you do the same thing here by subtracting the 13.37 from it, this is what you will have. So you have this 13 minus 7, you have 6, then you have 8, then you have 8 again, then you have 4. So you have 48.86. Now if you run this one off to the nearest whole number, you have 49 here. This one too, when you run it off to the nearest whole number, you have 102 here. So it means that we can go back to the table and go and look for all numbers between 49 and 102 and call them two standard deviation from the average. Two standard deviations from the average. So the ones I circled, I have come back. Now we are looking for 49 to 102. Let's see whether we'll cover them. So the first one, we cannot do anything about the first one. It's 107. It's outside this range, so we'll leave it. 54. is within 49 to 102. So at least the color of this will change. So this one is out. 90 is also in the range, it is covered. 91 is in the range, it is covered. 66 is in the range, we have covered it already. 97 is covered between 149 to 102. 89 is covered. 57 is covered. 102, 101 is covered. 94 is covered. And then we keep moving to the right. 61 is covered. 59 is covered. 59 is covered. And then 61 is also covered. 104 is not covered because it's up to 102. 59 is covered. 61 is covered. 99 is covered. 98 is also covered. 59 is covered. 45 is not covered because it's starting from 49. 102 is covered. 51 is covered. 57 is covered. 92 is covered. 116 is not covered. 89 is covered. So after two standard deviations, look at the numbers that are left. Look at the numbers that are left. 107 has not been covered after two standard deviations. 104 has not been covered after two standard deviations. 116 has not been covered. And then 45 has not been covered. So after two standard deviation, we couldn't cover 116, we couldn't cover 45, we couldn't cover 104, and then we couldn't cover 107. So we have 1, 2, 3, 4. Still, our story is not complete because we can't leave these numbers out. So we have to go ahead and do a third standard deviation. And after the third standard deviation, any number that is left out, we call that number outlier because it cannot be part of our normal data. And so let's do the third standard deviation to see whether we can cover that. Let's go back to our calculation. So the calculation I did after adding the third standard deviation, this is what we had. So we are doing standard deviation number 3. So this is number 1. This is standard deviation number 1. This is 2. Now we are doing the third one here. We want to put the result here, and then we'll do the same thing for this one, and then we put the result here, and then we can go and check. So let's do the computation. As at this point, we had 48.86. Let's subtract 13.27 from it. When you do that, you have 9 here like this. You have 5 here. You have 5 here. And then you have 3 here. So it means we can record 35.59 here. What about the addition? Here we have 101.94. We add our 13.27. This will give us 1, this will give us 2, this will give us 5, this will give us 1, 1. So it means we are having 115.21. So like we did for the others, we have to round it off to the nearest whole number. So to the nearest whole number, when you convert this one, it means the lower side you have 36. And then the upper side you have 115. So it means we are now going to look at our third standard deviation between 36 to 115 in our data. So when it comes to the data, the ones we couldn't cover, now our new target is 36 to 115. If you look at the figure here, 107 is in the range, so we have now covered the 107. Then let's look at the others. 36 to 115. 104 is within that range, so this is also covered. And then we keep moving. 45. 45 is within the range of 36 to 115. 45 is also covered. But look at the interesting one, 116. Our third standard deviation ended at 115. So it means that this 116 is an outlier. It cannot be part of our data, or it cannot be part of our expectation of the exceeding of targets. It means that when the company had 116, it was beyond our imagination, because all our thinking is that when the company does something that will go beyond our imagination, they cannot go beyond $115 million. But here we have one data, which is showing that one particular month, they were able to make 116. And so in statistics, this 116, because it is outside, three standard deviations, we call it as an outlier. It is not part of our thinking or imagination that we'll be able to sell to that tune. And that is what I wanted to teach you today. And so in a recap, this is what we have done. Number one, I've taught you how to find the average of every form of data. I've also taught you how to get an additional information to make the data understandable, and that additional information is called the standard deviation. I have also taught you the three standard deviations that explains all the data you can have from the average. And then I've also taught you that any data that is outside the three standard deviation is called an outlier. So there are certain organizations, they set certain targets which are not achievable. Any target that is not achievable is called an outlier within our calculation. And that is my last statement for today. Any question on what we have done today? If you have a question, you can put up your hand, then I'll respond to it. Any question?